Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Kristen McDonough and I'm your host for episode number 6 called The Chemistry of Fireworks. Today I will be discussing what a firework is composed of and how they give us a colorful display in the air. We all know that fireworks are these big explosions that shoot pretty colors in the air, and we typically see them around holidays or other fun events. But the real question is, what is a firework made of? Fireworks are typically composed of 3 different components: oxidizers, fuel, and a coloring compound, which are all located in a container known as an aerial shell. The shell is launched into the air with the use of black powder, which is essentially a gunpowder. A time fuse is also located inside of the aerial shell, which causes the explosion of the shell in the air to be delayed. The time fuse connects to an explosive, which then bursts the shell into pieces, shooting out the effect pellets. The effect pellets located inside of the shell determine the characteristics of the firework. These characteristics include the color of the firework, the shape of the firework, and any other special effects such as streaks that we see in the air or mini explosions along the way. The color of a firework is determined by the different elements located in these pellets and how they react with the heat of the explosion. So we first look at the oxidizing component of the firework. Oxidizers are oxygen-rich salts including potassium nitrate, or potassium perchlorate, or strontium nitrate. The nitrates are typically used for the initial upwards thrust and are located in the black powder. When nitrates react, not all of the oxygen gas is released, which results in a slower combustion. This makes them desirable for the initial launch since they won't cause the aerial shell to explode. The most common nitrate that is used is potassium nitrate. This decomposes into potassium oxide, nitrogen gas, and oxygen gas. We can see that there is still unused oxygen gas located in the potassium oxide. But oxygen gas is still created in this process. This is why we use them in the black powder. Chlorates are another type of oxidizer, however they are not typically used in fireworks anymore. The chlorate ions are composed of a chlorine atom and 3 oxygen atoms. When chlorates decompose, they release all of the oxygen gas located in the chlorate ion. However, since there are only 3 oxygen atoms, they are highly unstable and will explode if the salt is dropped. So instead, we use perchlorate, since they release all of the oxygen atoms in the form of oxygen gas, but are more stable than chlorates. Perchlorate ions are composed of 1 chlorine atom and 4 oxygen atoms. This structure is more stable than chlorates because the chlorine atom in the perchlorate ion is bonded to the maximum number of oxygen atoms. We can see in the Lewis dot structure of a chlorate ion that there is a lone pair electron attached to the central chlorine atom. In a perchlorate ion, there are no lone pair electrons attached to the central chlorine atom. Instead, the chlorine is bonded to 4 atoms. The oxygen released from the decomposition of the perchlorate reacts with a reducing agent such as a sulfur and carbon in the form of a fuel. The fuel is a source of electrons which is able to react with the oxygen in a combination reaction. In the combination reaction of oxygen gas and solid sulfur, gaseous sulfur dioxide is produced. This reaction is exothermic because more energy is released by the formation of the covalent bonds between the sulfur and oxygen atoms than is required to break the bonds between the 2 oxygen atoms in the oxygen gas. The formation of gas and heat causes the aerial shell to explode. After the explosion of the aerial shell in the air occurs, how can we see the different colored fireworks? The color of the fireworks are determined by the metal cation in the salts and the effect pellets. For example, copper oxide produces a blue color, strontium chloride produces a red color, sodium silicate produces a yellow color, calcium carbonate or calcium nitrate produces an orange, and a barium acetate produces a green color. Salts are used instead of metals because they are typically easier to disperse within the effect pellets and they're less reactive than metals. The different metal cations in the salts have different amounts of electrons in the outer shell. When the salts react with energy in the form of heat from the explosion, the electrons in the outer shell of the metal cation jump from the ground state to the excited state. When the electrons return from this excited state to the ground state, they release energy in the form of light. The amount of energy released from this process determines the color that we see. For example, a high energy that is released corresponds to a shorter wavelength, which would then result in a more blue-violet color. On the other hand, a low energy that is released will result in a longer wavelength, which would then give you a more red or orange color. When we look at copper compounds, we see a blue color because it releases a lot of energy when the electrons travel from the excited state to the ground state. So the colors we are able to see while watching the fireworks explode in the air are all determined by the different metals that are within the shell. The red, white, and blue fireworks we all see on the 4th of July is just chemistry in action. Fireworks have always held a special place in my heart. Every 4th of July, me and my family go to the beach to watch a fireworks display. We always have had a lot of fun watching the fireworks every single year, and each year gives us new family memories. I think most people can relate to the joy that fireworks give, whether it be on the 4th of July or at baseball games or any other fun event. Learning about how fireworks work chemically has given me the opportunity to connect one of my favorite holidays to chemistry. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.